All right, let's jump right into today's explainer. We're looking at a pretty groundbreaking curriculum called Computational Legal Ease. It's a training framework built specifically to pull lawyers and law students out of that traditional static document mindset and push them into what we can call a dynamic calculus perspective.
Okay, let's dive into this. What happens when a contract stops being just a dead piece of paper and literally becomes an active, living, breathing machine? That is the core question we're exploring today, and it honestly changes absolutely everything about how we look at the law.
Here is our roadmap for this explainer. We'll move from static to active, decouple instructions from data, understand data primitives, break down the machinery of execution, and then finally, peek into the future of mechanized law. Let's get started.
Starting with Section 1, From Static to Active. This right here is our first huge paradigm shift. On one side, you've got a classic legal concept, performance, actually fulfilling contractual obligations. On the other side, we have the software equivalent, a runtime, which is the execution of programmed instructions. The curriculum draws this direct, undeniable line between the two. We really have to leave behind the mindset of traditional paper drafting and step fully into the realm of active system design.
So what exactly is a runtime in this context? Well, technically, it's the period when a computer program is actively executing. But if we adopt this calculus mindset, we view it as a system running from start to finish. It's the actualization of your legal logic happening in real time. It's actively enforcing the rules you wrote.
To really wrap your head around this, think of a musical composer. You are designing a system beforehand, hitting play, and watching the stage performance execute start to finish. Modern legal engineers are basically composers, orchestrating verses, choruses, and loops. You design the logic completely up front, so when you finally press play, the obligations literally fulfill themselves.
Moving on to Section 2, Decoupling Instructions from Data. Now this brings us to a massive focus of this curriculum, which is training law students to mentally and practically separate the active machinery of execution, the instructions, from the passive material being processed, which is the data. On one hand, you have your active machinery, things like if-else conditions, loops, and variable assignments. On the other hand, you have the passive material, the data itself. Traditional legal drafting kind of tangles all this together in long, messy paragraphs. But to engineer law computationally, you absolutely must split them apart.
Let's dive into Section 3, Understanding Data Primitives.
So, what are data primitives? If you work in law, you actually use these every single day, even if you went to law school specifically to avoid math. Strings are just text values, like party names in a commercial lease. Numbers are quantities, like a monthly rent amount or a liability cap. And Booleans are true or false states. For example, was the rent paid on time? True or false? These are the raw passive assets that your active logic is going to process.
To really drive home why separating this stuff matters, just imagine a static Google Sheet. It's a flat, inactive database just sitting there full of raw data primitives. It's dead text. Now contrast that with an active JavaScript script. The script is dynamic. It's actively grabbing, processing, and manipulating that data. By decoupling the two, we're transforming law from that passive spreadsheet into a running, automated script.
Next up, Section 4, The Machinery of Execution. Okay, so now that we know our raw materials, how do we actively instruct this data during its runtime? The syllabus captures this hurdle perfectly. It notes that lawyers excel at legal logic but lack familiarity with programming grammar, syntax, and computer science design principles. The great news? If you're a lawyer or law student, you already have the complex logical skills for this. You map out if this, then that scenarios all day long. You just need to learn a new syntax to express it computationally. But that does mean overcoming a pretty major grammatical hurdle, the difference between association and equality. When we read standard English prose, we read left to right, right? But in coding, when you assign a value to a variable, you actually read it right to left. You take the data on the right and assign it to the container on the left. It takes conscious effort to rewire your brain to read legal instructions this way, instead of as a continuous flowing narrative.
So how does this actually translate into legal engineering? First, we convert standard legal conditionals into strict Boolean true/false if-else logic. Second, we map standard clauses into nested logic structures. And third, we implement tools like for loops to automate recurring administrative tasks. But here is the big warning the curriculum highlights. Traditional legal drafting loves the ambiguity of and or. When you try to force that kind of vague scope into strict deterministic Boolean code, it's going to collapse and break. Code demands absolute precision.
Zooming out for a second to the bigger picture, the curriculum leans heavily on the 1980s Unix philosophy. That's the idea of writing simple, modular programs that do one thing extremely well, and then having them communicate with each other via universal text streams. Why does this matter for law? Because this modular text stream approach is the ultimate future-proof foundation. It's the exact same architecture powering modern AI chatbots and clean JSON-based legal records. By building modular dependencies, if one underlying clause is updated or breaks, the entire downstream permission chain reacts predictably.
And finally, Section 5, Mechanized Law in the Future.
What does this paradigm shift from static text to computational execution actually mean for your career? The syllabus uses a brilliant transportation metaphor to visualize this macro evolution. For centuries, we lived in the analog era of direct law, basically the horse and buggy days of hand-drafted paper. Right now, thanks to legal engineering, we're in the current era of mechanized law. These are the cars. It brings hyperspeed, but it still requires human drivers and new regulatory guardrails. Finally, the future era is automated law. These are the autonomous, self-executing systems, the Waymos of the legal world.
As legal logic and computational machinery merge, two distinct career paths are really starting to emerge. First is the engineering path. This envisions developers acting as specialized legal authorities, kind of like how patent agents operate today without needing a full law degree. Then there's the lawyering path. This is where traditional practitioners naturally start operating with programming syntax simply because their everyday legal deliverables are evolving from paper documents into active software.
So I'll leave you with this final thought to ponder. Which path are you going to choose in this new landscape of automated law? Will you lean into the engineering side or adapt your traditional practice to speak the language of machines? Because one thing is for sure, the shift from static paper to active performance is already well underway. Thanks for checking out this explainer, and keep exploring.